Hello everyone, we are the product managers of Hoperf. We're delighted to introduce our LoRa and sub 1 GHz product lines here today. First, let's look at the LoRa and sub 1 GHz chip suppliers. In the field of IoT wireless communication, LoRa and sub 1 GHz technologies are gaining prominence and becoming a key focus for many manufacturers. As a professional wireless communication module supplier, our company closely follows industry trends and actively engages in the R&D and production of LoRa and sub 1 GHz related products, striving to provide customers with high-quality, efficient, and reliable wireless communication solutions. Regarding LoRa technology, we also have in-depth research and extensive practice. With its long-range, low-power, high-capacity, and other features, LoRa has rapidly risen in the IoT field. Our LoRa modules not only have excellent communication performance, but also integrate multiple functions, such as deep sleep and wake-up functions, which can effectively reduce power consumption, extend device battery life. This is crucial for some battery-powered wireless sensor network applications. In addition, we also provide module products related to the LoRaWAN protocol. As a wide-area network protocol based on LoRa technology, it has the advantages of high capacity, long range, and low power consumption, and is particularly suitable for LPWAN application scenarios. Our LoRaWAN modules are designed with full consideration of the balance between network latency and battery life, to meet the needs of low-cost wireless sensor networks powered by batteries. In terms of sub 1 GHz, we have a rich product line and mature technical solutions. The sub 1 GHz band has advantages such as long signal transmission distance, strong penetration ability, and good diffraction performance, and is particularly suitable for application scenarios with high requirements for communication distance and reliability. Our sub 1 GHz module products cover a variety of frequency ranges and can meet the needs of different regions and different applications. In the above three aspects, we work with well-known semiconductor manufacturers in the industry, such as Semtech, ASR, and Silicon Labs, using their chips to make modules to serve our customers. Hoperf has always adhered to the principle of being customer-oriented, continuously innovates and upgrades product performance to meet the market's diverse needs for LoRa and sub 1 GHz wireless modules. Meanwhile, we actively collaborate with upstream and downstream enterprises in the industry, jointly promoting the broad application and development of LoRa and sub 1 GHz technologies in IoT. Now, let's explore LoRa technology. As an advanced wireless communication technology, LoRa shows great potential and advantages in IoT. First, LoRa modules have deep sleep and wake-up functions. This enables them to sleep when communication isn't needed, which drastically cuts power consumption. When data transmission is required, the module can auto-wake, quickly resuming operations. This flexible power management is crucial for IoT devices that need long operation on batteries. It is undoubtedly essential. It effectively extends device life and reduces maintenance costs. From a technical perspective, thanks to spread spectrum modulation and forward error correction coding gains, LoRa can achieve about twice the communication distance of cellular technology. This means that, at the same frequency band and transmission power, LoRa signals can travel farther, covering broader areas. The long communication range endows LoRa with the excellent gene to use star network topology. Star network topology is simple, easy to deploy and manage, where a central node can communicate with multiple edge nodes, enhancing network scalability and flexibility. More importantly, as LoRa is a spread spectrum modulation technology, wireless signals with different spreading factors are orthogonal. Specifically, on the same channel, the 7 wireless signals with spreading factors from SF6 to SF12 don't interfere with each other. This orthogonality allows, within the same frequency band, multiple signals with different spreading factors to communicate simultaneously, which greatly improves spectrum utilization. This is highly valuable in the wireless communication field with limited spectrum resources. It is a very precious characteristic. It allows more devices to work simultaneously on the same frequency band, without interfering with each other, enabling the construction of large-scale IoT networks. To sum up, thanks to its low power consumption, long range, high capacity, and high spectral efficiency, LoRa is becoming a key option in IoT wireless communication. Let's explore LoRaWAN technology further. LoRaWAN, a wide area network protocol based on LoRa, employs a star topology network. This structure offers high capacity, long range, and low power consumption, making it ideal for LPWAN scenarios. In the star topology, end devices communicate directly with base stations, which collect and forward data. This simplifies network deployment and management, enhancing scalability and flexibility. For battery-powered, low-cost wireless sensor networks, WSNs, LoRaWAN is specially optimized. It balances network latency and battery life. On one hand, via rational scheduling and data transmission mechanisms, it minimizes end devices' communication time and frequency, reducing power consumption and extending battery life. On the other hand, it ensures timely data transmission and network response speed, meeting applications' network latency requirements. This optimization enables LoRaWAN's wide application in smart homes, smart agriculture, smart cities, and many other fields. In short, with its unique protocol advantages and optimization strategies, LoRaWAN offers an efficient, reliable, and low-power wide-area network solution for IoT applications. It plays an important role in promoting the development of the IoT industry. Let's take a look at Hoperf's LoRa module product roadmap together. Since 2014, LoRa technology has made remarkable progress in productization. In 2014, Semtech launched early LoRa chip products, such as the SX127X series, which laid the foundation for LoRa's promotion and application. In 2016, with LoRa technology's maturation and growing market demand, more LoRa module products were launched, such as the RFM95 module, which saw further performance and functional improvements. In 2018, LoRa technology continued to evolve. Product line was enriched. Modules like RFM97C and RFM98P were optimized in communication distance, power consumption, data rate, to meet diverse customer needs. Meanwhile, Semtech, the LoRa technology leader, continuously drives chip technology innovation and upgrades, providing the core driving force for LoRa module product renewal. By 2020, LoRa products had formed a relatively complete product system, covering products ranging from low power, short range to high power, long range. For example, modules like RFM6501 and RFM68LC perform well in specific application fields, meeting diverse customer needs for LoRa modules. In 2024, with the further expansion of the IoT market and increased awareness of LoRa technology, the demand for LoRa products continues to grow, and product performance and functions are continuously optimized and expanded. Besides SIM-Tag, other chip manufacturers like ASR have made significant progress in LoRa chips. The launch of chips like ASR650X and ASR6601 offers more choices for LoRa module products and promotes the widespread application of LoRa technology in various fields. These chips have their own advantages in performance, power consumption, cost, etc., offering flexible chip solutions for LoRa module manufacturers, which helps to further reduce product costs and enhance market competitiveness. As can be seen from the product roadmap, LoRa technology is continuously developing and evolving with an increasing variety of products, improved performance, and expanding application fields. It also reflects Hoperf's active investment and efforts in the research and innovation of LoRa modules. Now, let's take a look at Hoperf's LoRa module product portfolio. First, let's look at the RFM90C module. It uses the SX1262 chip, supports multiple modulation methods such as LoRa GFSK-FSK, with an operating frequency range of 150 to 960 MHz, able to meet the frequency requirements of different regions and applications. Its spreading factor range is 5 to 12, which can be flexibly set according to the actual communication environment and distance requirements to optimize communication performance. The data transmission rate is 62.5 kbps, able to meet the data transmission requirements of general IoT applications. In terms of power consumption, the transmission current is 118 milliamperes. The receiving current is 8.8 milliamperes, which represents a good power consumption performance. Its receiving sensitivity reaches 137 dBm. Even in weak signal conditions, it can reliably receive data. The transmission power is 22 dBm, which provides sufficient signal strength for long-distance communication. The module size is 16,162.8 millimeters. Compact size facilitates integration into various devices. Product model covers common frequency bands such as 433 MHz, 868 MHz, 915 MHz. Next is the RFM91SC module, which uses the SX1268 chip and also supports multiple modulation methods. With operating frequencies of 433-470-780 MHz, suitable for specific frequency band application scenarios. The spreading factor range is 5 to 12. The data transmission rate is 62.5 kbps. The transmission current is 135 milliamperes. The receiving current is 8.8 milliamperes, which represents excellent power consumption control. The receiving sensitivity is 137 dBm. The transmission power is 22 dBm, which ensures good communication performance. The module size is 16,162.8 millimeters. There are also 3 models of the product, targeting different frequency bands. Each has its own module. The RFM68LC module uses the LLCC68 chip. Supports multiple modulation methods such as LoRa GFSK-FSK, with operating frequencies covering multiple bands such as 433-470-868-915 MHz, which means a wide frequency coverage. The spreading factor range is 5 to 11. The data transmission rate is 62.5 kilobits per second. The transmission current is 125 milliamperes. The receiving current is 8.8 milliamperes, which represents good power consumption performance. The receiving sensitivity is 129 dBm. The transmission power is 22 dBm, and the module size is also very small. The RFM95C module uses the SX1276 chip, with an operating frequency of 915 MHz. The spreading factor range is 6 to 12. The data transmission rate is 37.5 kilobits per second. The transmission current is 134 milliamperes. The receiving current is 12.5 milliamperes. Power consumption is kept within a reasonable range. Receiving sensitivity reaches -138 dBm. It can stably receive data even in weak signal environments. The transmission power is 18.3 dBm. It can meet the communication needs of medium distance. The RFM95P module also uses the SX1276 chip. It operates at 868-915 MHz. It is suitable for applications in these 2 frequency bands. Its heat generating current can be as high as 650 milliamperes. At a maximum heat generating power of 30 dBm. The receiving current is 13 milliamperes. Receiving sensitivity is -136 dBm. The transmission power is 30 dBm. This gives it a clear advantage in applications requiring long-distance communication. The RFM98 module uses the SX1278 chip. It operates at 169433470 MHz. It is suitable for application scenarios in these frequency bands. The spreading factor ranges from 6 to 12. The data transmission rate is 37.5 kilobits per second. Power consumption is also excellent. Receiving sensitivity is -140 dBm. The maximum transmission power is 20 dBm. The RFM98P module also uses the SX1278 chip. It operates at 169433470 MHz. The size difference from the previous one is 35.40, 183.85 mm. The module size is a bit larger. In summary, our LoRa module product portfolio is diverse, covering different chips, modulation methods, frequency bands, power consumption levels, and size specifications. It can meet the needs of various IoT application scenarios. Whether it is a small sensor network sensitive to power consumption, or wide area IoT applications with high requirements for communication distance, we can provide corresponding module products to create efficient and reliable wireless communication solutions for customers. Next, let's take a look at the LoRa WAN module product portfolio. First, let's look at the RFM6601 module. It uses the ASR6601 chip. Supports multiple modulation methods, such as LoRa GFSK-FSK. Operating at 4334708689115 MHz. It can meet the frequency band requirements of different regions. The spreading factor ranges from 5 to 12. The data transmission rate is 62.5 kilobits per second. Transmission current is 108 milliamperes. Receiving current is 10 milliamperes. Receiving sensitivity reaches -138 dBm. Maximum transmission power is 22 dBm. Module size is 18,162.8 millimeters. The universal interface is UART serial port, supporting 3 working modes, class ABC. It is suitable for different LoRa WAN network application scenarios. The RFM6601SE module uses the ASR6601SE chip, supporting the same modulation methods as RFM6601, and the operating frequency is the same. The main difference is the size of the module. The RFM6505 module uses the ASR6505 chip, using LoRa, GFSK, GMSK modulation method, operating at 4334708689115 MHz. Similarly, its module size is 16,202.8 millimeters. The interface is serial communication, supporting 3 working modes, class ABC. The RFM6501 module uses the ASR6501 chip. Supporting modulation methods are also 4334708689115 MHz. Transmission current is 107 milliamperes, 22 dBm. Receiving current is 9 milliamperes. Receiving sensitivity is -137 dBm. Transmission power is 22 dBm. The module size is very small, only 16 by 16 millimeters. The interface is UART. So the LoRa WAN module product portfolio is in chip selection, modulation method, frequency range, power consumption level, receiving sensitivity, transmission power, and module size type have been carefully designed and optimized. It can meet the diverse needs of different customers in LoRa WAN network deployment. Whether it's constructing large-scale urban-level IoT applications or setting up small private LoRa WAN networks, we can offer corresponding module products to create efficient, stable, and reliable LoRa WAN communication solutions for customers. Now let's take a look at the sub-1 GHz module product portfolio. First, let's look at the RFM69 module. It uses the SX1231 chip, supporting multiple modulation methods such as FSK, GFSK, MSK, GMSK, OK, operating at 433868915 MHz. With a supply voltage of 1.8, 3.6 V, it can adapt to different power supply environments. Transmission current is 45 mA plus 13 dBm. Receiving current is 16 mA. Power consumption performance is also excellent. Receiving sensitivity reaches -120 dBm. Its communication interface is SPI. The RFM23A020 module uses the EFR32FG23 chip, supporting multiple modulation methods such as OK, GFSK, GMSK, OQPSK, operating at 433868915 MHz, which means a wide frequency coverage. With a supply voltage of 1.8, 3.8 V, it is more adaptable. Transmission current is 77 mA, 20 dBm. Receiving current is 5 mA. Power consumption is well controlled. Receiving sensitivity and transmission power are also excellent. Its interface can be UART or SPI, making it convenient to connect and communicate with different devices. The RFM25A12 module uses the EFR32MG25 chip, supporting multiple modulation methods such as 2G, FSK, OQPSK, YSUN OFDM, operating at 470868915 MHz. Its power consumption performance is also excellent. Receiving sensitivity is -110 dBm. Transmission power is 16 dBm. It can provide stable communication performance. The module size is 24,191.85 mm. The last module is the RFM92LR module. It uses the LR1121 chip, supporting LoRa FSK GFSK modulation methods, operating at 434868915 MHz and 2.4 G. It supports both SUBG and 2.4 G bands, which means wider frequency coverage and application flexibility. With a supply voltage of 1.8, 3.7 V, which is highly adaptable. Transmission current is 110 mA, 22 dBm. Receiving current is 8 mA. Power consumption performance remains excellent. Receiving sensitivity reaches -138 dBm. Maximum transmission power supports 22 dBm. The interface is SPI. Our sub-1 GHz module product portfolio, in chip selection, modulation method, frequency range, and other aspects, has been carefully designed and optimized. It can meet the diverse needs of different customers in sub-1 GHz wireless communication applications. Next, let's quickly look at the main features of the RFM23A020 module. This is a high-performance sub-1 GHz SoC wireless transceiver module. It has abundant resources and powerful functions. It has 22 GPIO pins, PC7 not included. These pins can be used to connect various external devices and sensors, providing extensive expansion capabilities for the module. It supports secondary development, making it convenient for customers to carry out customized design and function expansion according to their needs. The module is equipped with 512 kilobytes flash and 64 kilobytes RAM. It avoids system crashes caused by insufficient memory, ensuring smooth operation and high reliability of the module. In terms of communication protocol support, RFM23A020 supports multiple communication protocols such as Connect Networking, Sidewalk, and WM Bus. In terms of modulation methods, it supports multiple modulation technologies such as OK, GFSK, GMSK, OQPSK DSSS. Each of these modulation methods has its own characteristics, which can adapt to different communication environments and requirements. Maximum transmission power reaches 20 dBm. In terms of application scenarios, RFM23A020 is widely used in smart metering, smart homes, building security systems, smart cities, municipal infrastructure, industrial applications, commercial lighting, and many other fields. We have multiple models of modules based on different frequency bands, mainly including 4 models. RFM23A020-433S2, operating frequency 433.92 MHz. RFM23A020-470S2, operating frequency 470 MHz. RFM23A020-868S2, operating frequency 868 MHz. And RFM23A020-915S2, operating frequency 915 MHz. Overall, the RFM23A020 module, with its abundant resources, powerful processing capabilities, diverse communication protocol support, flexible modulation methods, high transmission power, and wide range of applications, has become an excellent product in the sub 1 GHz wireless communication field. It can provide efficient and reliable wireless communication solutions for various IoT applications. Let's take a look at the RFM23A020 module and its actual communication distance test in real-life scenarios. The test conditions were a working voltage of 3.3 V, a temperature of 25 degrees Celsius, humidity of 74%, an oscillator frequency of 39 MHz, operating frequency of 915 MHz, modulation mode of OQPSK, data rate set at 9.6 kbps, and an antenna with a gain of 3 dB. Under these conditions, we conducted an actual communication distance test of the RFM23A020 module. The test results showed that the actual communication distance of the RFM23A020 module reached 1.3 kilometers. This indicates that the RFM23A020 module, when operating in the 915 MHz frequency band and using OQPSK modulation with a 3 dB gain antenna, is capable of achieving a long communication distance, which can meet the wireless communication distance requirements of many IoT application scenarios. Next, let's look at the main features of the RFM25A12 module. It is a high-performance sub-SoC wireless transceiver module. It stands out in resource allocation and functional characteristics. For example, it has 35 GPIO pins, PC7 not included, for its GPIO port, which provide extensive expansion capabilities for the module. Its processor is a 32-bit ARM Cortex M33 CPU, with a main frequency of up to 97.5 MHz. It has 1,152 kilobytes of flash and 256 kilobytes of RAM. This large capacity flash memory can store more program code. The communication protocols support multiple modulation methods, including GFSK, OQPSK, and YSUN OFDM. We have 3 module models based on frequency. RFM25A12, 470S2, operating frequency 470 MHz. RFM25A12, 868S2, operating frequency 868 MHz. And RFM25A12, 915S2, operating frequency 915 MHz. 3 modules for different frequency bands. The RFM25A12 module, with its abundant resources, powerful flash and RAM, and support for multiple communication protocols, has become a high-performance product in the sub 1 GHz wireless communication field. It can provide efficient and reliable wireless solutions for complex IoT applications and offers efficient and reliable wireless solutions. Next, Let's look at the main features of the RFM92LR module. RFM92LR is a powerful wireless transceiver module. It supports commonly used frequency bands, 434 MHz, 868 MHz, 915 MHz, and also supports the 2.4G frequency band. The modulation methods mainly include sub-GHz band supports LoRa and G, FSK modulation, and the 2.4G band is similar. In addition, RFM92LR also supports the S-band, 1.9 to 2.1 GHz, for satellite communications. This gives the module unique application value in special scenarios, such as in remote areas or at sea where traditional communication infrastructure is scarce. Data can be transmitted over long distances and monitored via satellite communications. In terms of application scenarios, RFM92LR is widely used in smart metering, smart homes, building security systems, smart cities, municipal infrastructure, and industrial applications. To sum up, the RFM92LR module, with its dual frequency support, diverse modulation methods, broad protocol compatibility, and rich application scenarios, has become a high-performance, multifunctional module product in the field of wireless communication. Next, let's learn about typical application scenarios of LoRa and sub-1 GHz technologies. LoRa and sub-1 GHz technologies, with their significant advantages of long range, low power consumption, and high capacity, have found wide application in many IoT fields. First, in traffic control and parking lot management. These technologies can be used for the control and monitoring of smart traffic lights. By real-time traffic flow data acquisition, the timing of traffic lights can be optimized, improving road traffic efficiency. In parking lots, space occupancy monitoring can be realized, vehicle guidance and automatic billing, enhancing the management efficiency and service quality of parking lots. In street lighting, LoRa and sub-1 GHz technologies can realize remote control, dimming, and status monitoring of street lights. Street light brightness can be automatically adjusted according to actual needs, which can meet lighting needs, and also achieve energy saving and emission reduction. And street light failures can be detected in a timely manner, reducing maintenance costs. In terms of energy management, these technologies can be used for electricity meter data collection in smart grids, transmission line monitoring, and remote monitoring and management of renewable energy generation equipment, improving energy utilization efficiency and power supply reliability, promoting the intelligent development of the energy industry. Smart metering is another key application area. By embedding LoRa or sub-1 GHz modules in water meters, gas meters, etc., remote meter reading and automatic billing can be realized, improving the accuracy and timeliness of metering data, and reducing the cost and error of manual meter reading. In environmental sensing, these technologies can be used for air quality monitoring, water quality monitoring, and weather monitoring. Sensor-collected data can be transmitted in real time to monitoring centers, providing a scientific basis for environmental protection and disaster early warning. In smart city construction, LoRa and sub-1 GHz technologies are widely used in smart trash bin monitoring, smart water management, and smart community services, enhancing the refined management level of cities and the quality of life of residents. In the industrial internet field, it is also a place where these technologies can be fully utilized. They can be used for condition monitoring of industrial equipment, fault early warning, and production process optimization, improving the efficiency and quality of industrial production, and reducing equipment maintenance costs and downtime. In intelligent warehousing and logistics supply chains, these technologies can achieve real-time cargo positioning, inventory management, and logistics tracking, enhancing operational efficiency and accuracy, and reducing operational costs. In smart agriculture, LoRa and sub-1 GHz technologies can monitor soil moisture, enable precision irrigation, and oversee livestock breeding, helping farmers boost agricultural productivity and quality, and achieve intelligent and sustainable development. In short, with their unique advantages, LoRa and sub-1 GHz technologies have diverse application cases and broad development prospects, significantly propelling the vigorous development of the IoT industry. Lastly, let's examine our LoRa module shipment over the past years. Market trends indicate that the demand for LoRa and sub-1 GHz modules is growing continuously. In recent years, with the rapid development of IoT and the increasing demand for LPWAN, LoRa and sub-1 GHz technologies have gained market favor thanks to their unique advantages. Their applications are expanding, and the market size is growing. Regarding shipment volumes, Hoperf's annual LoRa module shipments have increased yearly. By 2024, the total shipment volume of LoRa modules had reached 4.1 million units. This data shows the high market recognition and strong demand for LoRa modules. For Hoperf, facing the continuous growth of market demand, it is essential to boost R&D investment, optimize product performance, and enhance production efficiency to satisfy the growing market demand for LoRa and sub-1 GHz modules. Also, it is crucial to strengthen cooperation with upstream and downstream enterprises in the industry to jointly promote the perfection and development of the IoT ecosystem. Thank you all for attending this training session. Thanks.